In this example, we're going to combine present value of an annuity or a payout annuity with a sinking fund. We're going to use one to inform the other. So you want to give your kid $200 per month while they're in college for 6 years. It will be paid out of an account earning 1.8% interest compounded monthly. How much needs to be in the account for your kid to receive payments? Okay, that's your payout annuity. That's your present value of an annuity. Then, how much should you deposit each month if you have 17 years to save? This is going to be our sinking fund. So how this is going to work is we're going to determine how much needs to be in the account so that we can withdraw $200 per month for 6 years. And then we're going to use that amount in step one as our goal amount. So it's present value of an annuity followed by a sinking fund. And we're going to do those in succession. So let's go ahead and do present value of an annuity. Here's our formula for present value of an annuity. We want to do $200 per month. That's what our monthly payments are going to be. We're going to do it for 6 years with 1.8% interest, and it's going to be monthly. So to capture that data, I always write all my elements to the side of my problem so I know exactly what I'm plugging in and where. So if I plug in all these values, my formula is going to look like this. Sometimes formulas might use PMT for payment. Sometimes they use D. I prefer D, a single letter, but same idea. I'm going to make the payout of $200. So that's where that's going. Let's go ahead and simplify our fractions, and then we'll also take care of our exponent as well. Okay, so 0.018 over 12 becomes 0.0015, and our exponent becomes negative 72. And I'm just doing PEMDAS. So I'm going to continue with my parentheses, adding 1 to 0015. All right, so now that I have that taken care of, I'm going to take 1.0015 and raise it to the negative 72. And now I'm in the home stretch. So I'm going to continue to work the top of the fraction. Okay, I'm going to put 0.1022997654 divided by 0.0015 in my calculator just to get a single decimal. So now I have 200 times 68.199 blah. And I'll multiply those two numbers together. This is the amount, $13,639.96872. This is the amount that we need to save up to. I need to have $13,639 and some change in order to be able to pay my kid $200 a month while they're in college for 6 years. So I'm going to use this as the goal amount for my sinking fund. So here's my sinking fund formula. And what's going to happen is that this amount needs to be my goal. But I still need RN and T. So we've got 1.8% interest still. It's still monthly, but now I have 17 years to save up to it. So if I look at all my values that I'm plugging in, RN and T came from the problem itself, but A, my goal amount, my accumulated amount, that came from the previous part. That came from the present value of an annuity. All right, so let's go ahead and plug this in. And I'm going to go ahead and I'm going to kind of combine some steps here since we've been doing this, I think, for a while now. All right, so my 0.018 over 12 becomes 0.0015. I'm going to add that to 1 to take care of the parentheses in the denominator. And then I'm also going to tackle 12 by 17 in my exponent to get 204. So now I'm going to go ahead and take 1.0015, raise that to the 204. Then I'm going to finish off my denominator. And now my fraction, I'm going to take 0.0015 divided by 0.357, etc. So I'll just get a single decimal. Boom. All right, so I've got 13,639.96872 times 0.0041937,983. And I'm going to multiply those together. And since I am now at my final answer, now I can round. Notice that in no point in the previous slide or in any of the steps I took, I did not round. You want to keep as many decimals as your calculator is showing you until the very end. Otherwise, you're going to perpetuate these rounding errors, and it'll be off enough by the end of all those steps that you'll be outside of your tolerance for the homework platform. So make sure to keep all of your decimals until the very, 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 very end. And so here, now that I know how much I'm depositing each month for 17 years, I can say, okay, it's $57.20.